So let's say that this is you, and let's say it's a nice day outside. We've got a sun shining. Let's say it's about 70 degrees outside, and let's say you've been doing a bunch of exercise. And one thing that's going to happen when you do exercise is that your body is going to produce a lot of heat. And the reason for that is you have muscles, like this quadriceps in your leg and like your heart, that are going to be very active when you're doing exercise. And all of the reactions that make them active end up releasing heat. And so a problem that your body might face in this situation is how does it maintain its core body temperature of 98.6 degrees? Now, one of the ways that your body can get rid of this excess heat produced by your muscles is to sweat. But there's another way that it gets rid of this excess heat produced by your muscles. And that's what I'd like to talk about here. And that way involves your skin. And to find out more about it, let's look at a zoomed in picture of a little piece of your skin. So here is the surface of the skin, which I've drawn in pink. And while the skin is pink, and below your skin, a little bit deeper, you're going to have some blood vessels. Now let's say this is maybe an arteriole. And this arteriole will be supplying your skin with blood and with oxygen via the blood. So the way it's going to do this is to send off little capillary beds into the skin. And these capillary beds, of course, consist of very fine blood vessels with high surface area that will allow exchange of oxygen between the blood and the tissue. But what you have to realize about your skin for our purposes is that it kind of acts as insulation. And the reason for this is that oftentimes it's not a nice day out, and oftentimes you're not doing exercise. So when it's a cold day out and you're maybe just sitting outside, you don't want to lose too much heat. And so in those cases, it's great to have this insulation that keeps the heat from down below, and from this arteriole, for instance, that keeps that heat from diffusing out too quickly. So it's really just like your house, which during winter you want to have insulation to prevent loss of heat. But these little capillaries that go to the surface of the skin, as you can tell, they kind of bypass all this insulation and they go right to the surface. And so the heat from the blood going to these capillaries will have a much easier time of getting out. And this analogy to the house is that these little capillaries are like little windows that allow heat out past the insulation in the walls of your house. So one thing that you're going to do when you're trying to get rid of heat, so now we're no longer talking about winter, is, well, what would you do in your house? If it were really hot inside the house and you had these windows that were just kind of, not open too wide, what would you do if you were feeling really hot in your house? Is you'd open up those windows wider. So that is exactly what your body is going to do when your body is overheating. So here we have our skin again, and here we've got our arteriole running through the deeper part of the skin. What your body's going to do is it's going to open up that window wider, and so it's going to dilate those capillaries over here, and it's going to make them much wider than they were. And this is known as vasodilation. It'll vasodilate those capillaries because what's going to happen when these capillaries are vasodilated? So do you think that more or less blood is going to be passing through these capillaries in this situation or in this one? And obviously, more is going to pass in the capillaries in this situation. And now in this case, we have a lot more blood going up into these capillaries, and therefore a lot more loss of heat to these surroundings. And so this is what happens when it's hot out and when your body wants to get rid of heat so that it can maintain its nice core temperature of 98.6. And by the way, something we should ask is what's so special about 98.6? Why do we want that temperature? And the answer is that your body has, as you know, tons of chemical reactions occurring all the time. And as you've learned in any chemistry classes you've taken, you learn that temperature affects the way that reactions are carried out, how fast they're carried out, and where the equilibrium is, etc. And that might sound, confusing if you don't know much chemistry. But the point is that all the machinery and all the chemistry of your body works optimally at this temperature. And that's why you want to maintain it. Now this is what happens when it's hot out. And when it's cold out, what do you think is going to happen? Well, when it's cold out, you're going to want to close the windows. You're going to want to close these windows that allow heat out. So you're going to do the reverse. You're going to make your capillaries as small as possible, And so as a result, you're going to have less heat at the surface of your skin. And that's why if it's a cold day outside and you walk around, when you feel your hands, they feel extremely cold. And that's because your body has made all the capillaries in your skin as thin as possible so that you lose very little heat. And because they're thin, this whole surface area of your skin becomes very cold. Now, as kind of a review, we also asked the question, maybe this has been bothering you for the whole lecture so far, but how does your body regulate the size of these vessels? And the answer is that all these blood vessels have little bits of smooth muscle around them. And these smooth muscle cells, when they contract, when they squeeze, they make the vessels smaller. And when they relax, they allow the vessels to be bigger. And the way that your body tells these smooth muscle cells to squeeze or not to squeeze is just through nerves. Your body literally sends impulses through these nerves that tell these smooth muscle cells whether they should be contracting or whether they should be relaxing. And this concludes Unit 1, Lecture 6.